So in order to explain how a light bulb works is what to tell you what light is. Light is electromagnetic energy, and light is expressed in the form of waves. Those waves consist of energy, and the longer the wavelength, the least amount of energy. The higher the wavelength, the more energy there is. So we, as humans, we can only see visible light. In everyday life, orange, purple, red, blue, they're all within the visible light spectrum. While these other lights, such as microwaves, like the microwaves that heat up your food, you cannot see that. There's actually light being put onto it, but you just can't really see the light that's being put on to the food. And then these are like gamma rays. I'm not necessarily sure what they're used for, but that's another source of light that we cannot see. So we can only see within the visible light spectrum. Just to get that out of the way, just wanted to get that out of the way. So now we're going to talk about how a light bulb works. So in order to do that, I'm going to draw a circuit. Okay, a circuit with a light bulb and a battery source. Positive side and negative side. There's a light bulb. Sorry for the terrible illustration. And there's the filament. So, as everyone so commonly knows, that this side of the battery has a large amount of electrons. Too much. There's too much. While this side is lacking electrons. So, there's a flow of electrons through the light bulb all the way to the positive side. So they may gain positive electrons also. And when the process is complete, you have a dead battery. Okay, so, and within this is usually copper wire, because copper wire, it can easily transfer electrons between one and another. And copper wire is mostly in everything. Your charger, to your TV, everything. So what's actually happening, yes, there is a transfer of electrons that's causing the filament that's creating energy for the light bulb to fill up or to emit light, but actually there's electric energy. It actually creates separate electric energy outside of the copper wire. There's actually separate energy outside of the copper wire. And you may not see it, but this actually is. And there's also magnetic energy that's happening outside of the electricity. Because the transfer of electrons creates these electric fields and the magnetic fields also. So there's also magnetic fields. So, also around the battery too. Still transfer of electrons happening there also. It goes like that way. So according to a law, chemistry law, it says that you hold your finger with all these fields in place. You hold your finger like this, and then, is it the right thumb? Yes, you hold your right hand, and you sort of squeeze the fields of energy. When you do that, it points you to where the energy goes. Your thumb points it. So that means all the energy is transferring to the light bulb. That's how it gains its energy to emit light. Now, you can see here, it's kind of an invisible force between the battery and the light. Electricity creates an electric current outside of the electric field and a magnetic field, and those together create a great source of energy that emit to the light bulb. So, what happens when that energy is gained by the light bulb, or in a better perspective to say, the filament within the light bulb, because that's what usually emits the light. That's what it does. That's what eliminates the light. So in order to explain that, we'll draw the filament. So the filament is usually made up of one element or so, something like that. So let's say it's made of silicon. So the silicon atom, we're going to draw a silicon atom model. And there's an electron on the outside. Okay. So when it receives all that electric current and that magnetic field, that kind of causes the electron to fall. And when it causes the electron to fall, because in order to fall or rise up from the shells, it has to have energy. It's like going upstairs. You have to have a certain amount of energy to go upstairs or downstairs, basically. It requires energy from both. That's how it works in shells, okay? So when it falls down, it releases energy, actually. No. So whenever you fall down, whenever you go downstairs, see how it's easier? So when it goes down, it actually releases energy in the form of photons. Photons gets emitted from when it goes down at energy level. And when it goes down at energy level, it releases photons. And those photons, guess what? Carry electromagnetic radiation. Get it? Electromagnetic radiation. Electron, electro. That is electricity part of it, the electricity field part of it. Magnetic is the magnetic field part of it. They both have electric current that they gained within the circuit. That electric energy got transferred to it. So did the magnetic energy. That's why whenever the electromagnetic, whenever that energy is transferred to the atom, causes the electrons to fall. And when the electrons fall, they emit energy in the form of combined form of electromagnetic radiation. Now, electromagnetic radiation is light that you can see within the visible spectrum. It all depends how strong the photons are. Some are strong, some are weak. Some you may see, some you may not. Thank you. Subscribe to my channel. And we will, this is one of my first videos, and I also talk about more chemistry related concepts, but also algebra, and also algebra, sometimes history, rare cases though. And I'll see you later.